Now, in this video, we discuss about the numerical problems based on the theory which we have studied. And there is a question: a force F equals to minus K. A force F equals to minus K y j cap y I cap plus x j cap, where K is positive constant, acts on a particle moving in xy plane. There is a particle moving in xy plane starting from the origin. So there is a xy plane, x axis and y axis. A particle started from the origin. The particle is taken along the positive x-axis to a point A, 0. The particle moves in a positive x-axis and particle goes to the point A, and the coordinate is A, 0. The x distance is A and y distance is 0. And this is the position vector, which is represented by vector r1. So vector r1 is equals to, in terms of position vector, vector r1 is given by a I cap plus 0 j cap. A I cap plus 0 j cap means r1 equals to a I cap, and then parallel to the y-axis. Then particle goes parallel to the y-axis to the point A, A. So there is a point A, x distance is A and y distance is also A. So there is a coordinate and the point is B, which is A, and name it R2 vector. So R2 vector is, in position vector, it is represented as A I cap plus A j cap. A I cap plus A j cap. This is the R2 vector. So these two positions of the particle is given when a force F equals to minus K y I cap plus x j cap acts on the particle which is situated at the origin. Then the position vector of the particles are R1 and R2, and joining these two positions we get the displacement vector. So AB is the displacement vector. OA and OB are the position vectors. So first we calculate the displacement vector. So it can be written as OA vector plus AB vector equals to OB vector. And let the displacement vector is given by delta R. So from triangle law of vector addition, we can write OA vector plus AB vector equals to OB vector, and AB vector is equals to OB vector minus OA vector, and AB vector is represented by delta R. So delta R vector, which is the displacement vector, equals to OB. OB means vector R2 and minus OA. OA means vector R1. So the R2 vector is A I cap plus A j cap, and R1 vector is A I cap. So delta R vector, we get A I cap minus ai cap cancel, and we get the displacement vector delta r equals to a j cap. Delta r equals to a j cap. Now we have to calculate the total work done by the force on the particle. So total work done W equals to F into delta R vector. F vector is given. So F vector is minus K y I cap plus x j cap. And delta R vector we have calculated A into J vector. A into J vector. Now minus K is a constant. So x into J, xj vector into aj vector. So j dot j becomes 1. So it gives xa or ax. So the work done K equals to, work done W equals to minus KAX, and the value of X is A. The value of X is A. So put the value of X equals to A. So at X equals to A, we get the work done equals to minus KA, and at the place of X we write A. So the result, the work done W equals to minus KA square. Work done W equals to minus KA square. So we get the result, the total work done by the force on the particle is minus KA square. So when the force is applied on the particle is situated at the origin, that position vectors are given a comma 0 and a comma a. This is r1, this is r2. This will be the resultant vector or displacement vector delta r. So we calculate delta r and we write r1 and r2 in terms of position vector. Then we use the formula for work done. Work done equals to F into displacement, means F into delta r. Now next question, question number 2. A force F equals to, a force F equals to I cap plus 5 j cap plus 7 k cap. I cap plus 5 j cap plus 7 k cap acts on a particle. Acts on a particle and displaces it through, and displaces it through S equals to 6 I cap plus 9 k cap. S equals to 6 I cap plus 9 k cap. This is the displacement vector. Vector S equals to 6 I cap plus 9 k cap. So calculate the work done. Calculate the work done. If force is in Newton, if force is in Newton and displacement is in meter, and displacement is in meter. So we have given the force vector and displacement vector. So directly we use the formula work done equals to force into displacement. So work done W equals to F dot S, and force vector is I cap plus 5 J cap plus 7 K cap dot 6 I cap plus 9 K cap. And by dot product, I dot I is 1, so 1 into 6, we get 6, K dot K1 and 7 into 9, 63. So 63 plus 6, 69 joule of work done. So the result is 69 joule. In this question we are given force and displacement, and directly we use the formula F into S. Question number 3. A gardener pushes a lawn roller A gardener pushes a lawn roller through a distance of 20 meters. Through a distance of 20 meters. If he applies a force of 20 kg weight, if he applies a force of 20 kg weight, if he applies a force of 20 kg weight in a direction inclined at inclined at 60 degree to the ground, 60 degree to the ground, then find the work done by him. Find the work done by him. The value of G is given 9.8 meter per second square. So the question is, a gardener pushes a lawn roller through a distance of 20 meters. The distance we have given S equals to 20 meter, and he applies a force of 20 kg weight. F equals to 20 kg weight, and 1 kg weight equals to 1 kg weight is equals to 9.8 Newton. 1 kg weight equals to 9.8 Newton. So 20 kg weight is equals to 20 into 9.8 Newton. So we convert the kg weight into Newton. So 20 into 9.8 Newton. And the direction inclined at 60 degree to the horizontal. Theta is given 60 degree. So the horizontal component of force will be F cos theta, means F cos 60 degree. So we use the formula W equals to F cos 60 degree into S, or Fs cos theta. So Fs cos 60 degree. F cos 60 degree is the horizontal component of the force. F cos 60 degree is the horizontal component of the force, and S is the displacement. So we put the value of F 20 into 9.8, and displacement is 20, and cos 60 degree 1.2, means 0.5. So 20 into 20, this is 400 into 9.8 into 0.5, and after solving we get 1960 joule. So the result is 1960 joule work is done by him. Work done by the person will be 1960 joule. The next question, question number 4. A person is holding a bucket by applying a force of 10 Newton. A person is holding a bucket by applying a force of 10 Newton. A person is holding a bucket by applying a force of 10 Newton. He moves a horizontal distance of 5 meters. He moves a horizontal distance of 5 meters. And then climbs up a vertical distance, and then climbs up a vertical distance and then climbs up a vertical distance of 10 meters. So find the total work done by him. Find the total work done by him. So we have given that a person is holding a bucket by applying a force of 10 Newton. He moves a horizontal distance of 5 meters. Person moves a horizontal distance of 5 meters by applying a force of 10 Newton and is holding a bucket. And then he climbs up a vertical distance of 10 meters. Means the person covers a horizontal distance as well as the vertical distance. So for horizontal distance, the angle between force and displacement. A person is holding a bucket by applying a force of 10 Newton. He moves a horizontal distance of 5 meters. So force is given 10 Newton for horizontal distance. We find the work done in two segments. Work done when he covers a horizontal distance and when he covers a vertical distance of 10 meters. So for horizontal, we have given force equals to 10 Newton. F equals to 10 Newton. The displacement S is 5 meters. And person is holding a bucket. So force acts in upward direction and the displacement is in horizontal direction. So in this case, the angle between force and displacement, means theta is 90 degrees. When the person is moving horizontally by holding a bucket, so the force on the bucket acting in vertically upward direction and the person moving in horizontal direction, so angle between them is 90 degrees. So work done W1 equals to F S cos theta. So F S cos 90 degrees. So 10 into 5 into cos 90 0. So the work done in horizontal direction is 0. When a person moves in a horizontal distance of 5 meters, then the work done in this case is 0. Now for vertical motion, he climbs up a vertical distance. Of 10 meters. So in this case, the force acting and the displacement both are in same direction. Therefore, angle between force and displacement is 0 degree. So for vertical motion, angle between force and displacement is 0 degree because both act in the same direction. Both acts in the same direction. Displacement is in upward direction and force also acting in the upward direction. So both have the same direction. And work done W2 equals to Fs cos theta The value of theta is 0 degree. So Fs cos 0 degree. And the value of force is 10, displacement is 5, and cos 0 is 1. So work done is 50 joule. So in the second case, when he climbs up a vertical distance, the work done is, in this case, he climbs a distance of 10 meter. So displacement is 10 meter and the work done is 100 joule. So total work done in moving a horizontal distance and vertical distance, W equals to W1 plus W2, and W1 0, W2 is 100, so total work done, F total, W total is 100 joule. Total work done by the person is 100 joule.